is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to the Nobody's Code. In this is the way the module looks, and it looks very similar to a module called Burglar Alarm, for those of you who are familiar with that. This module is a boss, and it is actually quite a simple boss to actually do. So let's get right into this and see exactly what we need to do. So, as I mentioned before, this is a boss, and what we're going to essentially be doing here is we're going to be noting down a series of 8-digit codes that is going to be given on each stage. So, let's start doing that. So in this case, we got stage 1 here, and we have 331-83320. Okay? And that's going to be our first stage, and we're going to modify this stage later on down the line when all non-ignored modules have been solved. So, what we need to do here is we need to just start off with modules. And the nice thing about this mod is that there is no back and forth input that is required. It's all work that is done at the end. So let's get to this, and let's get all of our stages here. Stage 2, as you can see in the top right, that's our stage indicator. We have 1500-1543. Stage 3 is going to be 776-14058. We have, for stage 4, we have 005-42804, excuse me. Okay. Stage 5 is going to be 301-05924. Stage 6 is going to be 3444. Then 2593. And then finally, for our last stage here, we have 780-72241. And for now, what we're going to do is we're now going to be getting into the input here. So now, what we're going to do is, what's going to happen here is that once all solvable non-ignored modules have been solved, the stage display will turn blank, and the number screen will have a list of 5 stages. So in this case, as you can see right now, it says stage 7 on here. And what this means is that you can cycle through these stages by pressing the clear button, and this also clears your input if you happen to input any numbers at this point. So, what we're going to do is we're going to toggle these in the correct order. We want to make sure that we cycle these, and we get them in the exact order that they're listed. So in this case, we're going to start with 7. We're going to start with, then we're going to get 6, then 5, then 2, and then 3. Okay. So these are going to be the stages that we're going to be working with here, and once you can click the clear button again to go back to the first stage, in this case, stage 7. So these are going to be the 5 stages that we're going to be working with here. Now, let's get into the bulk of this module. So now, what we need to do is we now need to input another 8-digit code back into the module in order to solve this thing. So, we're going to enter in the 8-digit code using the number pad and press the submit button to solve the module. And note that you cannot see the code that you entered at the time. So all you simply have to do is simply input 8 numbers. They won't appear on the display, but you just simply have to input all 8 of them and simply hit the check mark. So now, let's get into the solving process. So, what's going to happen? So we're going to go through the 8 tables below, and we're going to add the digit that you get from each of the tables to their stage 1 digits of the module. In this case, what this refers to is this refers to the position of the stage 1 digits. So let's pop this up real quick. So for number 1, we're going to be focusing on the first position, in this case the first 3. Number 2 is the second 3. Third number is the 1, 8, and so on and so forth until we do all 8 digits. As you can see, those are of 8 tables. So this module is going to work similar to the burglar alarm process, where essentially you're going to start on the top left of the table, check if that condition is true. If it's not true, you're going to go to the else, and then you're going to look at another condition, and then you're going to get a series of numbers to add here. Now, the reason why I say a series of numbers is some of them have 2 digits. And how exactly do we determine this? Upon reaching a pair of digits, if the last digit of the serial number is even, we will use the left digit, and otherwise we will use the right digit. So, is our last digit of the serial number even? It is indeed even, so in this case, we're going to be using the left digit of the 2 if we happen to get a pair. Some of them don't have pairs. In this case, that's pretty straightforward to do. And once we get a digit from these tables, what we're going to do is we're going to add the digit you get from each of the tables to their stage 1 digits on the module. So in this case, we can do, for example, if we reach this position, it's simply going to be 3 plus 1, and it's going to give us a total of 4, for example, and so on and so forth. It's a fairly straight addition module. And if any of those numbers are greater than 10, you'll simply just take the least significant digit, or modulo 10 for those of you familiar with it. So now, one other thing that we need to note down about terminology before we get into the solving process, is when we have cases of number, whatever it might be, for example, number 1, it's going to refer to the number from that stage shown on the module. If there is a dot on both sides of the screen, this number is notated as number 5. So, what exactly does this mean? So if we take a look at the 5 stages that we just got here, and in this case, the reason why I say that the order is super duper important is because of the fact that we're going to be noting this down like this. Number blank is simply going to be, in this case, stage 7 was the one that appeared first. So that is going to be number 1 in this case. Stage 6 was the one that appeared second, stage 5 appeared third, stage 2 appeared fourth, and stage 3 appeared the fifth. So now, when we get into the solving process of this, in this case, number 1 is going to be focusing on stage 7 in this case. And now we're going to take a look at this rule. Let's actually get into the solving process. So now, number 1, in this case, stage 7, has both the 3rd and 6th characters in the serial number. In this case, we're going to take a look at the 2 digits. Does it happen to have 4 or 4 in there? So does stage 7 have a 4? It does indeed. So in this case, this rule is true. So now we're going to focus on this column, and we're going to take a look at this condition right here. So number 2, in this case, stage 6, doesn't contain a 3. It does indeed. Has 2 of them. So in this case, this is true. And now we get our number for the state, which is going to be a 9, because remember, we're using the last digit serial number, wants us to use the left digit. So now what we're going to do is we're going to add 9 to the 3 we got up here. 9 plus 3 is going to be 12. So in this case, we get a total of 2 for this stage, for that. Okay. Next up, and I'm just going to get rid of these, but that gives you an idea of exactly what we're doing here. Number 4 does not contain a 9. In this case, does stage 2 contain a 9? It does not contain a 9, so in this case, that is true. And number 1 contains 0. In this case, does stage 7 contain a 0? It does indeed. We have one right there. And in this case, we're going to get a total of 0. In this case, we don't have to worry about any left or right digits. We're simply not going to add anything to 3. Stage 2 is going to be a 3. Okay. Or position 2, rather, is going to be a 3. All right, let's continue on. Number 3 contains a 9. Does number 3, in this case, stage 5, contain a 9? It does indeed. That's true. And the last digit of number 5, stage 3, is even. In this case, the last digit is indeed an 8, so that is even, so we're going to be using these guys right here. So, we're going to be adding 8, because we're using the left digit always. 8 plus 1 is going to be a total of 9. Number 2 contains a 7. So number 2 in this case is a 6. 6 does not contain 7, so now we're going to go to the else condition here, and we're going to focus on this condition. Both number 4 and number 5, both stage 2 and 3, contain a 3. Let's take a look. Stage 2 and 3. This has a 3. Stage 3 does not have a 3. So in this case, this is not true. So we're going to be using the else condition right here. And that is going to be a 2 that we're going to add to the 4th position. So 2 plus 8 is going to be 10, or simply 0 in this case. So now, here's where we're going to get into some of the more interesting rules. So, when it happens to be referencing, for example, 3 or more numbers, what this is going to be referring to is this is solely going to be referring to the stages that we got here. So, numbers mentioned from the table will only refer to the 5 stages listed. So it's going to ask about 3 or more numbers are even. We don't really care about stage 4 at all. In this case, it's the only one that we haven't gotten. We do not care about stage 4 or any other stages that we didn't get in those 5 stages. Very important to note down. So, let's continue on. Number 3 contains a 4. In this case, number 3 is a 5. Stage 5 does indeed contain a 4. So now, let's take a look at this next rule. 3 or more numbers are even. Now, what's important to note is that these numbers, what this means is that if we take a look, we need to simply see if the last digit of each of these is even, because what these essentially are is these are 8-digit codes, and these are going to be treated as 8-digit numbers in this case. So, in this case, let's check if 3 or more numbers end in an even digit. We have stage 5 ends in 4, stage 3 ends in 8, but the rest end in odd digits. 6, 7, and 2 end in odd digits. So in this case, there's going to be 3 odd, not 3 even. So in this case, we're going to take a look at the else condition, and we're going to add 3 to the 5th position, which is going to be a 6. Any number contains 11, or 1, 1 back to back. And in this case, I don't think so. I'm pretty sure that this is referring to these two being in the exact same position, like next to each other. But I don't believe it does. So in this case, there is stage 2 here that has 2 1s. But as far as I'm aware, these are not the same. This is not the same as the 1 1 being next to each other. The way that it puts it in quotation marks, or single quotes rather, does make it a bit interesting. It makes me believe that they are next to each other. So in this case, that is not true. Else, any number's third digit is a 5. Let's take a look. So 765, no, no, no. 2, 3, nope. So in this case, that's going to be an else case. Right. So else, we're going to add 4 to this. The sixth digit is a 3. 3 plus 4 is going to be 7. Exactly 2 numbers contain both 5 and 3. Let's take a look. This does not contain either of them. This contains 5 and 3. This contains 5 and 3. This contains 5 and 3. 2, 5, and 6 contain 5 and 3. So in this case, it's not exactly 2 numbers. Else, no more than 3 numbers contain a 9. No more than 3. This does not contain 9. This does not contain 9. And in this case, that is true regardless. There's only 2 that contain a 9 that we had stages for. So in this case, this rule is indeed true. For the 7th digit, we're going to be adding 4 to the 2. So in this case, 6. Okay, and finally, any number contains both 1 and 5. Yes, stage 2 does. Number 2 is divisible by 3. So what we're going to do is we're going to pop out our handy-dandy calculator for this last bit. Okay, so we're going to take number 2, which in this case is stage 6, and we're going to see if it's divisible by 3. 3, 4, 4, 4. 2, 5, 9, 3, divide by 3. It is not divisible by 3, so in this case, we're going to take a look at the else. And now we're going to add the last digit of number 5. Number 5 in this case is going to be stage 3. Stage 3, last digit is an 8. 8 plus 0 is going to be an 8. And now we have our 8-digit code that we're going to input into the module. So in this case, we've got 23906768. Hit the check mark when you're done. As you can see, there's no digits displayed. And just like that is a solved module. It's a fairly simple mod to do, just you need to be careful with some of the terminology used. And in this case, I was indeed right about any number containing 1, 1. They have to be together, because there is 2 1s in number 2, but they are a couple spaces apart from each other, as you can see. So, that's very important to note. Let's take a look at one more example. This module, as you can see, is fairly simple to do, and stages themselves don't really make that much of a difference. I happen to have 6 stages total here, and only 5 are relevant, so it's perfect. But let's take a look at one final thing, and then we will do this. This module itself is not that bad. You can't actually begin any of the work until afterwards, so this module is just noting down 8-digit codes until the end of the bomb. However, it's fairly simple to do, and the work itself, not too hard to do. It's basically just burglar alarm, but a boss, essentially, with some catches, I will be honest. So, let's run one more bomb, and let's get this thing going. Okay. Alright. 223-29716. Stage 2 is 0143-2915. 276-24325. 818-01906. 851-456. 15. 704-04413. 901-773-65, and then now we're going to get our stages here. Let's see what we get. All right, so for so number 1 is 2. Then we have 7 for 2. Then we've got 5. Then we have 3, and then we have 4. Okay. So let's take a look. And let's see what we got here. And also, by the way, our last digit of the serial number, what are we looking at here? We're looking at an odd in this case. So we're going to be using right digits in this case when we get to these tables. So right digit is going to be your answer. So let's get right into this. Okay, so for number 1, the first one has both the third and sixth characters. In this case, stage 2, let's take a look. Stage 2, we're looking for a 6 and a 1. Does stage 2 have both of those? They do not. So in this case, that's not true. Number 3 contains duplicate digits. Does number 3, in this case 5, contain duplicate digits? It does indeed. It has 3 5s. So in this case, we're going to go with that one. Now remember, we're using the right digits this time because the last digit is odd in the serial number. And we're going to be adding 6 in this case to a 2, which is going to be an 8. Okay. Next up, number 4 does not contain a 9. In this case, does stage 3 contain a 9? It does not, so in this case that is true. Number 1 contains 0. Does stage 2 contain a 0? It does indeed. It actually leads with a 0, so in this case that is true. And we're going to be adding nothing once again, giving us 2 for our second number. Number 3 contains a 9. In this case, stage 5. Does that contain a 9? It does not. The first digit of number 4 is odd. In this case, stage 3 begins with an even digit, so in this case that is not true. We're going to be adding 7 to stage 2, the third one, which in this case gives us a 0. 10 equals 0. Number 2 contains a 7. In this case, stage 7 does indeed contain a 7. Both the last digit of the serial number and number 3 are even. Well, already that is false, because both the last digit of the serial number and the number 3 are even. The last digit of the serial number is not even, as we've determined already. As a matter of fact, I don't really know why it even has a right digit, because that's just not possible to reach. There's no way that you can have the right digit if the last digit of the serial number is even. Okay, anyways, I digress. So in this case, we're going to take a look at the else condition here. So the else condition is a 0 in this case. We reach the 0. For number 4, 2 plus 0 is equal to 2. Number 3, in this case, stage 5, contains a 4. It does indeed, yes. So that is going to be this condition true. 3 or more numbers are even. So in this case, we've got 2, 7, 5, 3, and 4. We're avoiding 6. We only have one even digit. Wow, we only have one ending in an even. That's fantastic. They do love their ending with 5s. Interesting. So in this case, that is not true. Else, we're going to be adding 3 to the stage. 3 plus 9 is 12, which is equal to 2. Any number contains an 11, a 1, 1 next to each other. In this case, we've got several 1, 1s, however, none of them are together. So in this case, that is not true. Any number's third digit is 5. No. Next. Okay? Else, we're going to add 5 in this case. 5 to the 6th number, in this case, is 5 plus 7, which is equal to 2 again. Wow, lots of 2's in this solution. Exactly 2 numbers contain both 3 and 5. This one does not. Well, we don't care about 6, though. This one does not, this one does not, this one does, and this one does. There's 3 of them, so there's not 2. No more than 3 numbers contain a 9. This one contains a 9, this one contains a 9, and this one contains a 9. So there is exactly 3. It says no more than 3, so it can have 3. Therefore, this condition is true. So in this case, we're going to be adding 3. Remember, using the right digit. So 3 plus 1 is going to be equal to 4. Okay? Any number containing both 1 and 5. Well, that's easy. Yeah, 7 does. So, cool. Number 2, in this case, stage 7, is divisible by 3. Check. So 901, 773, 65, divide by 3. It is not divisible. Let me just make sure I enter that in right. 901, 773, 65. Yeah, it is not divisible by 3. So in this case, we're going to be using the else condition right here again. So last digit of the number of 5. Last digit of 5, in this case, stage 4, is a 6. 6 plus 6 is a 12, or simply a 2. So now we're going to enter in 8202242, hit the check mark, and just like that is a solved module. A fairly simple module to do, and it is not that hard to understand. It's a nice little boss, though granted it does take a little while to note down 8 digits, but it's not the worst thing out there. It's basically a mixture of FT and burglar alarm. Forget this for those of you who don't know what that means. And that's all there really is to it. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.